we can calculate the capacitance, because the capacitance will be equal to the charge accumulation over the total voltage change during that process. So the charge movement, as we go from negative to positive voltage, this is the charge movement as the charge is flowing into the capacitor, at least as defined. This is the positive and this is the negative end of the power supply. As it's varying and becoming more positive on this end than this end, then the current's going to flow in that direction. And then backwards when the voltage trend reverses. So we're going to use this information to calculate the capacitance. And ultimately, it will be calculated by looking at the I dt relationship divided by the voltage change during these corresponding upward and downward voltage flows. The cool thing is to actually be able to see it. So the second part of it, or at least maybe the technical issue of this, is that to calculate these the areas underneath the curve, one more thing that Vernier, the Logger Pro software, will do for us. So there's actually a function where you can highlight a region in question in Logger Pro and have it integrate that, and it will give you the total charge directly. So we can fit it to a function and then integrate it ourselves, or we can just have the computer do it for us. So it's actually be relatively easy to calculate, to measure the total charge from Logger Pro. And the only questions we need to know then is the start to the end voltage, or the start to the end voltage over the regions where a charge is flowing one way or the other. So if you're halfway in between, you're told that charge is zero, right? So we got to look at only positive accumulation or positive charge flow and negative charge flow. Now what we're going to do with this, though, to physically calculate C, we're not going to do it with individual points. We're going to graph it and plot Q as a function of delta V. And hopefully, we'll get something that has some semblance of a linear relationship, the slope of which, from Logger Pro, should be equal to the capacitance. So it'll be a very direct measurement, but it will require that we use graphical analysis to calculate the charge flow in either direction as we measure it, and that we identify the regions where the voltage is changing in the appropriate corresponding direction. The cool thing is, we're not going to use a sine function because that's a little screwier to see, though it's kind of nice to see that you actually get a derivative relationship. We're going to use a triangular wave, which is basically an arctangent function, a repeating arctangent function. But that's essentially the idea. So there's not a huge amount here. It's just kind of nice to see it. We haven't fully talked about capacitance other than the introduction to it last week. And this is going to be a continuing topic for at least the next week, week and a half. So this is just sort of a start to what it looks like. And probably won't start this for 2 weeks, actually. The next week, in service on Tuesday. So we will have class on Thursday, not Tuesday, so we'll probably wrap up our discussion of electric potential. And then capacitance will follow on for Tuesday. In the sense of where we are. But at least we can kind of see it now. So go ahead and start setting up your equipment. You'll need a function generator, and I'm just going to let you guys figure this out. Some of you may know how to use them, some may not. I think there's a little bit of direction, but probably not very adequate direction. So this is where you think, this is where you have fun with, this is where you monkey around with, this is where I play with the chicken. So, and I got a couple different capacitors here. Frankly, I don't care which one you use. And I think the lab asks for a 100 microfarad capacitor. So it's up here. And again, microfarad, microcoulombs per volt. So it tells you, so for every volt of electrical potential difference you apply across a capacitor, a 1 microfarad capacitor would accumulate 1 microcoulomb of charge, 10 to the negative 6th power. So you think about it as farads, you circuit jockey, but if you think about it physically, it's charge per unit volt that will ultimately store and accumulate in these devices. So they're pretty cool. And you can start to see how they might be useful because of these time-varying effects. You can use them for phase shifts in electrical circuits. You can use them by changing the shape of signals. There's all kinds of good stuff. So, you guys get to work. You'll need a cord. You'll need one of these cables for your outputs from your power supply, if you will, your leads, your power leads. And you'll need a differential voltage probe to physically measure the voltage. And I think you have current probes. Oh, current probes are here as well. You may have current probes in your kits. So anything that appears to be missing, you'll need a voltage and a current probe, aka an ammeter and a voltmeter to plug in your logger probe. And most of these things should be in your kits. If they're not, they're definitely extras up here. So please ask if there's anything I can clarify, but I definitely wanted to stop talking so you guys can gals and get organized, realize.